Okay, let's go ahead and do chapter 23. It's about rates and ratio. A ratio is a relationship between two numbers, kind of a comparison, but definitely a relationship. An example right now would be the Diamondbacks. Let me look up on my phone real quick what their record is. I think they're about 55. No, they're 59 and 44. So what do those two numbers represent? Well, that's the wins to loss ratio that the Diamondbacks have right now. They have 55 wins and 44 losses, if I remember correctly. Pretty good. 59 wins and 44 losses. So their ratio is 55 wins to 49 losses. They're winning more than they're losing. The only team in our division right now that's beating us are the LA Dodgers, which they are off the charts right now. They're 72 and 31, almost a 70% winning average. That's huge. I don't think we're going to catch them anytime soon. But there's three rules that I want to talk about for ratios before we move on. Okay, the first rule is pretty straightforward. The ratio is in order by how we are asked. So if someone asks you for the win-to-loss ratio for the Diamondbacks, the win to loss, notice I said the word win first, and the word loss second, the win-to-loss ratio would be 55 to 49. When you're talking about your own team, usually you always do the win-to-loss ratio. When you're talking about someone else's team, then it would be opposite. So if they asked you for the Diamondbacks loss to win ratio, that would be backwards. It would be 49 to 55. By the way you do ratios, you put these two dots right there in between, and that shows the relationship. So this would be the loss to win ratio for the Diamondbacks. Okay, the next rule is you reduce just like fractions. So if you have a ratio that's 20 to, say, 5, you could reduce that. You find a number that will go into both of those evenly, common denominator. So that would be 20 divided by 5, which would be 4. 5 divided by 5 would be 1. So you can reduce 20 to 5. You can reduce that to 4 to 1. The next rule of ratios is that you leave ratios in fraction form. You would never change it to a mixed number. So for this one, 4 to 1, another way to write that would be 4 over 1. This could be 4 frogs to 1 fly. It's a bad ratio for the fly, isn't it? That fly is gonna get eaten. Bad ratio for the frogs too. They don't have much to eat. So you would never reduce this to 4 because then you wouldn't have any information about that one fly. Okay, so this is 4 to 1, and it would stay that way. Now that we've done that, let's go over a couple different ways to write ratios. You could have 13 to 15. You could have 13 and 15, or you could have 13 over 15. That's the same ratio written 3 different ways. So this could be it's just a comparison. Okay, here's your next problem. Let me move the computer a little bit so you can see. Alright, a team lost 3 games and won 7 games. What's the win-to-loss ratio? And this is a little bit tricky, so let me point out what they did here. We got to follow these 3 rules as we write a ratio. The order that's asked, it wants the win-to-loss ratio. So the win goes first, then the loss would go second. a team lost 3 games. A lot of people will put 3 right under the W. But it wants the wins first. So how many, because they put the 3 first in the problem, doesn't mean it goes first in the ratio. So it wants the win to loss. So how many games have they won? They've won 7. They've lost 3. So that's a little bit of a trick question. So this would be 7 to 3 or 7 over 3. Okay, this problem is a little bit tricky too as well. You have to follow these 3 rules. And so you have to ask yourself, what does the problem actually want you to get? So in a class of 28 students, there are 13 boys. What's the ratio of boys to girls? Okay, so we're going to go boys to girls. A lot of people would look up here and say, oh, 13 boys. So that goes right there. You are right. We have 13 boys to, oh, and the other number is 28. Are there actually 28 girls in the class? No, there are 28 students. So this is a little bit of, you have to think back to our missing number, missing add-in. So we have 2 things. You have 13 plus some number, and that equals your total number of students. There are 28 students in the whole class. So we have a missing add-in right here. So what we're going to do is, in order to find a missing add-in, you just subtract from that. So we're going to 28 minus 13, which is 15. So we have 3 things. We have boys, B for boys, 13 boys, girls, which is 15 girls, and then your total. Okay? So boys to girls would not be 28. You have to do this extra little bit of work. It would be 15. Different way to write that would be 13, 15, and 13 over 15. Almost running out of room there. Okay? So that's the ratio of boys to girls. So pay attention to what the problem's actually asking. Okay, Dr. Bob has 200 scheduled appointments in August. 50 people didn't show. In the medical world, these are called no-shows. What is the ratio of no-shows to shows? So what does it want? It wants no-shows to shows. Let's write that over here. N stands for no-shows. S stands for shows. So we want to put the no-shows first. We already know the no-shows. 50 people didn't show. Okay? How many people did show? Oh, there's another number up here, 200. Wrong. Because what is being asked is the ratio of no-shows to shows. 200 people didn't show. There are 200 people scheduled to come. Not all of them showed. Some of them didn't show. 50 people didn't show up at all. So how many people showed? So we're going to take 200 minus 50, and that will give us how many people showed. So 150 people showed. Okay? It's a pretty good show rate. So this is important that you guys think about what's actually being asked. And by the way, this is actually exactly what I did before I became a teacher. I was working in quality management for the past 5 years. I just switched back to becoming a teacher, and I would have to calculate data on this every single month. I'd have to determine what doctors were having more no-shows, and that way we could find something. Okay, well maybe we're not calling the people before their appointment. You know how you get a phone call the day before your appointment? I don't know if you know, but your parents know. If you have a dentist appointment coming up, your parents will get a phone call the day before to make sure that you remember to come to your appointment. Because people are always trying to lower the number of no-shows. So math like this is very important, and it's very useful, and I used it every day when I was trying to get people to come to their doctor's appointment. Which, if you think about it, it's very important to come to a doctor's appointment. This math actually saves people's lives because doctors saves people's lives. And if you don't know how to get people in, then the results could be dire. So this is a real life math situation that I hope you guys learn and pay attention to, because you might use this someday. Okay, so let's go ahead and solve this next problem. On a bike trip, Jeremy rode 60 miles in 4 hours. How many miles per hour? Miles is first, hours is written second. Okay, miles per hour did he average? So right here is our ratio, 60 to 40. 60 miles to 4 hours. So that's pretty fast for a bike. So I'm going to erase this. I'm going to write this ratio as a fraction. 60 miles in 4 hours. Okay, look at our 3 rules for ratios. Order asked, 60 miles in 4 hours, so we did that. Reduce like fractions. So let's go ahead and reduce this. We're going to divide top and bottom by the same number. And what would that be? Let's do 60 divided by 4. 4 divided by 4. That's going to reduce to 15 miles for every 1 hour. Go ahead and put your units of measurement here. 15 miles to 1 hour. So let's draw a picture. Right here I have a timeline. 0 hours, 1 hour, 2 hour, 3 hour, 4 hours. So every hour he's going to travel a certain amount of miles. We already determined that when we reduced the ratio there. So after 1 mile or 1 hour, he has traveled 15 miles down the road. 1 hour has elapsed, about the time of our class period. By the time our class period is over, he will have been 15 miles that way. So 15 miles, I would say that's about to Prescott Valley. So in an hour, can you see a guy riding a bike? Goes to Prescott Valley. Then the next hour, he is now 30 miles down the road at 2 hours. So he's been riding for 2 hours. So think about your next period class. After that class, he's in Mayer. That's about another 15 miles. I'm estimating on those. Then after 3 hours, he is now 45 miles down the road. And after 4 hours, he's on his way to Phoenix. Okay? So that is a little picture that kind of describes what is happening in this ratio here. Okay, you'll hear about gas mileage a lot when you're talking about cars. If you go to a car dealership and you're looking at cars to buy, you look in the window, they have a sheet of paper, and on that sheet of paper it'll tell you how many miles per gallon your car will get. So my car gets about 27 miles to every gallon. So if I burn a gallon of gas, think of like a milk jug, if you see gas in it, and it burns, it pushes the car forward. How many total miles can I get down the road further with that gallon of gas? That is 27 miles down the road for 1 gallon of gas. So how far could we travel with a 14-gallon tank of gas? So for every gallon of those 14 gallons I drive, I'm going to get 27 more miles down the road for every gallon. So 1 gallon, 27. Next gallon is going to be more and more and more. Okay, so what you're going to do in this situation, if you see a problem like this, you know that 1 gallon equals 27. 2 gallons, I'm going to get since I have twice as much gas, I'm going to get twice as many miles. So I'm multiplying 27 times 2. Okay, 7 times 2 is 14, carry the 1, 4 times 54. So with 2 gallons, I can drive 54 miles. Okay, 3 gallons, it would be 3 times 27. 4 gallons, 4 times 27. So continue that out, we have 14 gallons of gas. So I'm going to take 27 times how many gallons of gas I have? 14. Okay, so let's go ahead and multiply this out. 4 times 7 is 28. Carry the 2. 4 times 2 is 8. Plus 2 is 10. Placeholder 0. 1 times 7 is 7. 1 times 2 is 2. Okay. So, 378. I'm going to get 378 miles every time I fill up I get 378 miles. And so you can take this further. You could say, well, how much does it cost per gallon of gas? So now the ratio is how much money per gallon. But you could also do how much money it takes per mile. And calculate that out as well. So those are some different extra ratios you can do if you have free time and you want to do it. Alright, so this lesson is very important to our market research project that we're working on, and it helps us compare different products. I have right here a jug of 100% pure Vermont maple syrup. If you notice on the bottom here, you have how many fluid ounces there are. The size of this jug is 32 fluid ounces. So we want to know how much it costs per every ounce, because there are different sizes and different costs, and so you don't want to compare. You need a common unit to compare something by. So what we're going to do is we're going to think, okay, so this cost about $21 for 32 ounces. What you do is you take, you're going to write a little ratio, 21 to 32, which another way to write it is 21 ounces over, or $21 for 32 ounces. You're going to take top divided by bottom. So top, which is 21, I'll do this over here, 21 divided by 32. I'll put some zeros out here. 2 zeros because we want to convert this to money. Okay, 32 can't go into 21, so it'll have to go into 210. How many times will 32 go to 210? Well, I know that 33 will go into 100 3 times, so 33 will go into 200 maybe 6 times. So let's do this. 6 times 2 is 12. Here your 1. 6 times 3 is 18, plus 1 is 19. So let's read. 10 minus 2 is 8. 10 minus 9 is 1. So 18 is less than 32, so this works. So 32 will go into 18. Let's bring down a 0. 32 will go into 180 about 5 times. So 5 times 32. 5 times 2 is 10. Carry your 1. 5 times 3 is 15. Plus 1 is 16. So 65 cents. Let's erase this so it doesn't get confusing. So it's about 65 cents per every ounce. So right now we've reduced this. We have 65 cents for every 1 ounce of syrup. So if you ate a stack of pancakes, put an ounce of syrup on it, you just spent 65 cents for that 1 ounce of syrup that went on your pancakes. So this right here is it's called the unit cost. All right. So hopefully this helps you understand rates and ratio, and hopefully it helps you understand how to calculate some stuff on your market research project. I might do another video on more specifically on that. But that's pretty much all I have for rates and ratio. Have a good day.